So what we want to do is we want to set up an integral that has this as the place where the integration happens. Okay, so what we're going to do is we're going to describe where x goes. You don't have to draw these boxes, but I find it helpful to explain the thought process of what's going on. So we're going to describe where x goes, because we have a nice simple setup for x. So x goes from 0 to 1. Right, so we say, okay, x runs from 0 to 1. And now notice that the y value depends on where x is. When x is very small, we don't go up very far. Right? When x is a little bit bigger, we go up a little bit farther and farther until we're basically hitting 1. Okay, so the base of those slices is getting bigger and bigger as x gets bigger. So we always start off at y equals 0. And the height that we reach to is at y equals 1. Sorry, the height that we reach to is at y equals x. And now this is something that we can calculate out. Does anyone have any intuition for what this number should come out to? Oh, yeah, over here? Yeah, it should come out to a half. Why?
Because it's 25 degrees south.
A bit louder?
Because it's a triangle south.
Yeah, it's a triangle, right? So this thing has area 1, and now we're going to sort of make like a slice of cake or something, right? We've got we've got area at half and then height 1. So this thing should contain volume half. Okay, so we get here. Nice. Here. As expected, we get a integral that gives us the volume of the thing. So notice that our x was between fixed constants, right? But our y value changed depending on what slice we were looking at. So I just want to finish up by sort of making a theorem or a statement out of this, because we're going to come back to this notion of calculating area this way. If we've got a region and we integrate 1 over the region, that corresponding volume is equal to the area of the region we're interested in. So we're going to pick these topics up next week, and we're going to get into more details about how this stuff plays with Houdini's theory. Thank you.